Alright, so this is the 16th problem in the grind 75. This one is called ransom note. We are going to go over the solution, and basically this problem asks, given two strings, ransom note and magazine, we will return true if ransom note can be constructed by using the letters from magazine, and false otherwise. So basically we can think of magazine as our bank of letters, and anytime we see a letter in ransom note, we have to be able to pull it from our bank. And we've done a problem similar to this before, where we were checking to see if all the letters and all the counts of those letters in one string was the same as it was in another string. But now it just has to be less than or equal to all the possible letters that we have available, which is in magazine. And so I used a similar approach to that problem where I created an integer array of size 26, and that's going to represent the character counts. This new int array of size 26. And note that we're confined to lowercase English letters, and that's why we can do 26. So we're going to loop through our strings, and we're going to basically add characters, add to the proper spot in this character counts array if we are looking at the magazine, and take away from the proper spot in this array if we are looking at the ransom note. And what this represents is an array of all characters in the alphabet, all lowercase characters. And anytime we see one of those characters in either of these strings, we are going to want to either increment it if we're looking at the magazine, or decrement it if we're looking at the ransom note. And we don't actually know which one will be larger, which string will be larger, the ransom note or the magazine. So we're going to say for int I is less than the maximum of ransom note dot length. We have to use parentheses because we are using a string, and could be magazine dot length. Again, going to use parentheses. Let's make sure we have enough room. And we have to make that comparison. So while I is less than this, and we're going to do I++ as usual. We're going to say as long as we are within the bounds of, let's say, the magazine. So if I is less than magazine dot length, then we can say we are going to add it because we have that bank and we want to use those letters, and so we're going to add it to our char counts array. And the way that we do this is by going to that specific index in char counts. That specific index represents the character that we are looking at. So we're going to take magazine dot the character at I, and we are going to have to offset it by the lowercase a, because characters in Java are equivalent, they have like a number representation. So in ASCII, which I believe is lowercase letters, uppercase letters, numbers, they have certain numbers and they don't start out at 0. I don't believe lowercase a starts out at 0. So we want to make this offset be from 0, if this makes sense. So for example, say our whole array of characters is like this, and we know that lowercase letters are some subset. Say it's like this right here. our subset is represented by this, which would just be, in our case, 0, 1, and 2. And if, say, the current character is 4 in the actual ASCII code, then we want its offset to, we're going to get its offset, which would be 2, and that would be its proper position in here. Because if this is our subarray, lowercase a would be that starting letter, and so we'd subtract our current letter. We would subtract the lowercase a out of that, and that would give us the proper position in the char counts integer array. Hopefully that makes sense. And then we're going to repeat this logic for ransom note.length as long as I is within that bound. And this time, what we're going to do is get the character at ransom note dot char at appropriate spot I, subtract out from a, and I actually didn't do the proper operation here. So for magazines, we're going to want to add to that value that's currently there. For the ransom note, we're going to want to subtract from the value that's currently there. This is, again, our pool of letters that we're going to use. This is the letter that we're going to take from that pool. So that is the end of that for loop. Now we have the counts, and we're going to actually do another iteration, but this time we're going to go through this char counts array, and we're going to say for int, let's say counts, int count in char counts, we're going to say if count is less than 0, which means that we've tried to use more letters than we have access to in magazine, then we know we can't make our ransom note out of the magazine. So we're going to return false. But if we get through the entire char counts array and see that there is 0 or more, then we know that we can make the ransom note out of the magazine. And let me check for some tactical errors really quick. So what is this? Is there an extra parenthesis there? Possibly. Yeah. Okay, what is this? Math.max. There is a 0 in there. I don't know how that. Oh. I attempted to put a parenthesis there, but then it just registered as a 0. Okay, passes that. Should also pass the other tests. All right, and that is our implementation of this problem. What is it called? Ransom note. The complexity is O of n plus m, the time complexity, because we have to loop through, well, let's see. Is it technically O of n plus m? We're looping through the longest string, whether that be ransom note or magazine. So it would just be O of n plus, of just n, whichever is the longer string. And then we're looping through a constant right here. So this operation would be constant. So technically it would just be O of n, where n is the length of the longest array, or string. Sorry, strings and arrays are sort of the same, or you can handle them the same. And this approach is even better because we are not storing things in a hash map, which resizes. We are storing it in a fixed length array. And so this operation right here becomes constant time. And yeah, that becomes our overall time complexity, and our memory or space complexity is reduced because we're using that fixed length integer array.